So today in this class, we will start with exercise 3.6. The first question, solve the following pair of equations. So a pair of equations, right? By reducing them to a pair of linear equations. Oh, that means this given pair of equations, they are not linear. Okay, so we have to first reduce them. We have to first transform them into linear equations. And once we transform this given pair to a pair of linear equations, then we can use any algebraic method to solve, right? There are three algebraic methods for solving a pair of linear equations into variables, okay? Substitution method, elimination method, and cross multiplication method. So, like, how are they not linear? Question says they are not linear, so we have to reduce them to linear. So let's check how are they not linear. Okay, so what I'm going to do, I'm going to just take the first equation. Okay, just take the first equation and write them as it is given. Alright, now here the variable is in the denominator. In an equation, variable is not supposed to be in the denominator. So I'm going to rearrange this in a systematic order, in an appropriate order. 2 upon square root. Square root of x means the power of x is 1 by 2. Cube root means cube root. If it is cube root, then the power is 1 upon 3. Is it okay? Yes. So square root of x means x to the power 1 by 2. So 3 upon square root of y. So that means y to the power 1 by 2 is equal to 2. Now this implies 2 as it is. 2 is a coefficient, no problem. Now 2 upon x to the power 1 by 2. This x to the variable is in the denominator. If I bring up to the numerator, then I have to write x to the power minus 1 by 2. And then here also 3 y to the power minus 1 by 2 here. So I'm rearranging this, right, equation. Then what we find is, here the power of x is minus 1 by 2. Minus 1 by 2 is not 1. In order to be a linear equation, the power of the variable should be 1, right? Positive 1. But here it's negative of 1 by 2. Here the power of y also it's negative of 1 by 2, which is not linear. Is it okay? So what we have to do is, we have to first transform or reduce these equations, this given pair of equations, to linear. And then only we can simplify it further. Are you following me? Yes. We should start now. You are getting the concept now, okay? This given pair of equations, they are not linear. So what I'm going to do is, I'm going to transform them. I'm going to reduce them to linear. Alright? Linear equations. So how are you going to do? Okay? The same procedure follows for each and every problem. So I'm doing question number 1, Roman 2 first. So given pair of equations are, your given pair of equations are 2 upon square root of x plus 3 upon square root of y is equal to 2. This is your first given equation. Okay. Now what I'm going to do is, here your variable is x. Is it okay? And the power of x is not 1. So it's not linear. So instead of this variable x, I'm going to replace it by another variable whose power will be 1, and so we get linear. Okay? So how are you going to arrange this? It's very simple. Same question, same thing, same procedure follows for the rest. 2 upon square root of x. Can I write this as 2 times 1 upon square root of x? See? 2 times 1 is 2 upon square root of x. Upon square root of x. Same thing, right? No? And then 3 upon square root of y can be rewritten as 3 into 1 upon square root of. What I'm doing here is I am separating the coefficient and the variable ones. Is it okay? Writing it as 2 terms. No? Itu separate korobole try kori ase. No? Okay. So after this arrangement, you just make it as, since this is your first equation, we have done some arrangement, so you make it as equation 1. And the second equation also follows, and the second equation is 4 upon square root of x minus 9 upon square root of y is equal to minus 1. Here also the same thing, you try to separate the variable from its coefficient ones. So 4 upon square root of x, how do we write? 4 times 1 upon square root of minus 9 times 1 upon square root of is equal to minus. So this is your equation 2. Now you see, here we have 1 up, in the first equation we have 1 upon square root of x. Here also we have 1 upon square root of x. Okay? Here we have 1 upon square root of y. Here also the same position, we have 1 upon square root of y. The 1 upon square root of x is never linear, right? So in place of 1 upon square root of x, you put another variable. Say u with power 1. Is it okay? And instead of 1 upon square root of y, you put another variable. You substitute another variable, say v, whose power is 1. So what I'm going to do is put 1 upon square root of x as u and 1 upon square root of y as v. No? Then your equation 1 becomes, what will your equation 1 become? You're replacing 1 upon square root of x by u and 1 upon square root of y as v. Then your equation 1 becomes 2u, yes, 2u plus 3v is equal to 2. Here power of u is 1, power of v is 1 in your equation. So we get another equation number 3. Okay, now this is linear. And what will equation 2 become? Your equation 2 becomes 4u minus 9v is equal to minus 1. So we get a pair of linear equations in 2 variables now. That is equation 3 and 4. And in order to solve this kind of equations, we can use substitution, elimination, cross multiplication. It depends on what you want, and it depends on your equation as well. Here what I'm going to do is, I want to try by elimination. So I have to make the coefficient of one of the variable to be equal. Can I do like this? I'm going to multiply equation 3 by 3. If I multiply equation 3 by 3, this becomes 9v, no? Positive of 9v, and on the other equation we have negative of 9v. Is it okay? So opposite sign, no? Opposite sign, so I can add equation 3 and 4. Suppose what you want to do, if you want to eliminate u, suppose, then I'm going to multiply equation 3 by 2. If you want to eliminate u, then you have to multiply equation 3 by 2. Then this becomes 4u. On the other equation also the coefficient of u is 4. Same coefficient now. And then since they have the same sign, okay, both are positive, so we can subtract the equations. That also can be done. So let's do that then. So multiplying equation 3 by 2. Multiplying equation 3 by 2, then this, your equation 3 now becomes, you are multiplying, equation 3 by 2. 4u 4u plus 2 times 3v is 6v is equal to, so we get a new equation number. So now let's subtract equation 4 and 5. So subtracting equation 4 and 5. Here equation 4, 4u minus 9v is equal to minus 1. And your equation 5, 4u plus 6v is equal to 4. I'm subtracting. Subtraction means we change the order of the sign for the second equation, for the lower equation. So since this is positive, so we make it negative. Positive, so negative. This is positive, so we make it negative, right? 4u minus 4u gets eliminated. Minus 9v minus 6v minus 15v. Minus 1 minus 4 minus 5. Minus gets cancelled. So v is equal to 5 upon 15. 5 1 times is 5, 3 times is 15. So v is equal to 1 upon 2. We have obtained v. Now we want u. In order to find u, I have to substitute the value of v in an equation containing u and v, not x and y, okay? So in order to find v, I'm going to substitute v in which equation? Shall we make it as equation 3? In equation 3, right? Equation 3 looks more simpler. So from equation 3 means I'm going to substitute the value of v in equation 3. Your equation 3 is twice u plus 3v. So 3 times v, 1 by 3, right? Is equal to 2. Is equal to 2. So twice u plus here 3 cancels out, so we have 1, right? So twice u is equal to 2 plus 1, you transpose it as minus 1. So twice u is 1. That gives you to be 1 by 2. So you have obtained u, you have obtained v. But that's not it. Okay. Our actual variables are given to be x and y. So that is what we have to find. Alright. See, we have taken 1 upon square root of x to be u, right? Now, we considered 1 upon square root of x to be equal to u. Now we know u, so we can find out x. So this implies 1 upon square root of x is equal to u. But what is your u? 1 by 2. So if we cross multiply, square root of x times 1 is square root of x is equal to 2 times 1 is 2, right? I don't want the square root, I want x only. So in order to remove this square root, what do we do? Squaring both sides. Then square root of x, the holding square is equal to 2 square, right? So this implies square and square root cancels out. So x will be equal to 4. So the first solution is x equals to 4. The other solution, 1 upon square root of y, we consider it to be v. V is 1 by 3, we have obtained. So 1 upon square root of y equals to 1 upon 3. You can cross multiply. Then square root of y is equal to 3. So if you're squaring both sides, then square root of y, the holding square is equal to 3 square. Square root cancels out, that's y is equal to 9. Therefore x equals to 4, y equal to 9 is the solution for the given pair of equations. Alright? Okay. So we shall now continue with Roman 1, question number 1, Roman 1. So this is not linear, okay? This is not a linear equation. So I have to reduce it to linear equation, okay? We can check why it is not linear, but that's not necessary. So what I'm going to do is, first I'm going to write what is given. Given pair of equations are 1 by 2x plus 1 by 3y is equal to 2. You separate the coefficient from the variable here. Separate the coefficient from the variable. How are you going to do that? What is the coefficient here? 1 by 2 is the coefficient, right? Yes. So you separate the coefficient from the variable. So how am I going to write that? 1 by 2 into 1 by x. So 1 times is 1, 2 into x. So same thing, right? Just some rearrangements. 1 upon 3y, I can write it as 1 by 3 times 1 upon y. Yes, you are trying to separate out the coefficient from the variable. Is equal to 2. So that is your first given equation. I can make this as equation 1, right? And the other one, the other equation, 1 by 3x plus 1 by 2y is equal to 13 upon 6. The same thing I can do it here. Just try to separate the coefficient from the variable. What is your coefficient here? 1 by 3. So I can write 1 by 3 times 1 by x, right? Plus 1 by 2 times 1 by y is equal to 13 upon. Yes. Now see, we have 1 by x here, we have 1 by x here. So we can replace 1 by x by another variable, u, say, which is linear. We have 1 upon y in the first equation, we have 1 upon y in the second equation as well. So you replace it by v. So put 1 by x as u and 1 by y as v. Then your equation 1 becomes, what do you write? Equation 1 becomes 1 by 2 times u, right? Plus 1 by 3 times 1 by y. 1 by y is v is equal to 2. I can remove the denominators very easily now. You can just cross multiply, or you can just take LCM, cross multiply, then you get an easier equation. Shall we do that? So don't make it as equation 3 now. I want to rearrange a bit to make things more easier. LCM of 2 and 3 is 6. 2, 3 times is 6. Yeah, 3 times 1u is 3u. 6 divided by 3 is 2. 2 times 1v is 2v is equal to 2. 2 means 2 by 1. If you cross multiply, 3u plus 2v is equal to 12. That is equation number 3. Similarly, your equation 2 also becomes something like this. And equation 2 becomes, what does your equation 2 become? Equation 2 becomes 1 by 3 times 1 by x, but 1 by x is u, plus 1 by 2 times 1 by y, but 1 by y is v, so 1 by 2 times v is equal to 13 upon 6, right? So if we take LCM, 6, 2 times is 6, so 2 times 1u is 2u. Here we have 3v equals, see, are the denominators equal from both sides? We can cancel them out. So you have 2u plus 3v is, and this is your equation number 4. So equation 3 and 4 are your linear equations into variables. So we can solve them by any kind of method that you desire. This time shall we try with substitution method? I think that's no problem, right? Substitution method means, see, there are three equations or two equations, equation 3 and 4. Substitution method means we take one equation and find uc, right? That value of u we have to substitute in the other equation. Okay? So from equation 3, your equation 3 is 3u plus 2v is 12. Let's find u from here. 3u is equal to 12 minus 2v. So your u will be 12 minus 2v upon 3. So we have obtained u, but it is in terms of v. V thaki kena hi u pai ase. So we can make this as equation 5. Now, so let's substitute this value of u in the other equation 4, because we have obtained u from 3. So I have to substitute u in the other equation now. So substitute u is equal to 12 minus 2v upon 3 in equation 4. Look at equation 4. Equation 4, wherever there is u, I'm going to replace by this value. Equation 4 starts with 2u. So 2 times u. What is your u? 12 minus 2v upon 3. We can enclose like this. And then we have plus 3v is equal to 13. Right? I'm going to continue here. So 2 is going to multiply with both of these terms. 2 12 times, this implies 2 12 times is 24 minus 2 times 2v is 4v upon 3 plus 3v is equal to 13. What are we supposed to do now? Take LCM. Take LCM on the left side. LCM is 3 here. LCM is 3. 3 divided by 3, 1. So we have 24 minus 4v as it is. Okay. Here the denominator is 1. If the denominator is 1, this 3 is going to multiply the numerator. Is it okay? 3 times 3v is 9v is equal to 13. So 24 as it is. 9v minus 4v. Yeah, plus 5v upon 3 is equal to 13. Now we can cross multiply. 24 plus 5v is equal to 13. 3 times is 39. Right? So 5v is equal to 39 minus 24. So 5v is equal to 15. So that gives you v to be 3. Alright? So the value of v has been obtained to be 3. I hope it's correct. No? Now what I'm going to do, substitute this value of v in equation 5, then we get u. Okay? So from equation 5, your equation 5 is u equals to 12 minus 2v upon 3. 12 minus 2v, 2 into v upon 3. 12 minus 6 upon 3, 6 by 3. You have obtained u. But that's not it. That's not it. We need x and y. Now actually we started with putting 1 by x as u and 1 by y as v. Now finally 1 by x we have considered it to be u. So 1 by x is equal to, but now your u is 2. So 2 means 2 by 1. So if you cross multiply, twice x will be equal to 1. So the required value of x is 1 by 2. The same way, you have assumed 1 by y to be v, but v we have obtained to be 3. So if you cross multiply, 3v will be equal to 1. I mean, this is 1 by y, this is 1 by y. So 3y will be equal to 1. That gives you y to be 1 by 3. So x equals to 1 by 2 and y equals to 1 by 3 are the solution for these given equations. Alright? So we now proceed with Roman 3. You have a pair of equations. Let's check whether they are linear or not. Here you're given pair of equations. Given pair of equations are 4 upon x plus 3y is equal to 14, right? That's your first equation. Now you see, let's check whether they are linear. 4 upon x means, can we write 4 into 1 by x? Oh, you see, in order to check whether they are linear or not, you have to bring this variable x to the numerator. Then you have to write 4 and x is in the denominator. So if you bring this x to the numerator, I have to write x to the power minus 1. And then we have 3y here, right? See, here the power of x is minus 1. And if the power of a variable is minus 1, then it is not linear, right? Linear. In order to be linear, the power of the variable should be 1, not minus 1. So this is not linear. But in this case, you have another variable y. What is the power of this y here? Oh, y is linear. So no problem with this y, but with this x. So we have to replace this x by another variable so that it becomes linear. Alright. Now what you are going to do, first you try to separate this 4 and x. You try to separate the variable, its coefficient from its variable. Okay? Separate the coefficient from its variable. So how are you going to arrange this 4 upon x? 4 times 1 upon x, yes. Here already this term is linear, so there is nothing to be done, so just write 3y. Alright? And then you have to replace 1 by x by another variable which is linear, only that not 4y. So this is your equation 1. And then your second given equation, 3 upon x minus 4y is 23. Here also the power of y is 1, which is linear, so nothing to do with y. 3 upon x can be rewritten as 3 times 1 by x. Alright? Is it okay? So in equation 1 we have 1 upon x. Equation 2 also we have 1 upon x. So put 1 by x as any variable that you like. Say t. Let me take t now today. Okay, for this question. I can take u, you can take v. Okay, you can take any variable that you like. Why do as it is? Because it's linear, right? Then your equation 1 becomes, what does your equation 1 become? 4t, yes, 4t, because 1 by x is t, so 4t plus 3y is 14. So this is a new equation. And then your equation 2 becomes, 3t minus 4y is equal to 23. we can still work out with the elimination or by the substitution, elimination, or cross multiplication. I want to try out with the substitution again, okay, which seems to be easy for this question. So in order to do by substitution, what I'm going to do is I'm going to choose equation 3 and I'm going to find t. I'll get t in terms of y only, okay. That value of t we will substitute in equation 4. Okay, find y, very simple. So from equation 3, 4t plus 3y is 14. Then 4t will be equal to 14 minus 3y, right? Okay. So in that case, your t will be 14 minus 3y upon 4. It's not necessary that you will always find t. You can find out y as well. We can try that today. Okay, we can try out that. Suppose, instead of finding t from equation 3, shall we find y and see? Okay, we can do. Then 3y would be equal to 14 minus 40. So y will be 14 minus 40 upon 3. That's equation number 5. So we have obtained y from equation 3. Okay? So this value of y has to be substituted in the other equation 4. So substitute y is equal to 14 minus 40 upon 3 in equation 4. We have obtained y from 3. So I have to substitute in 4. Equation 4 is 3t. So 3t, right? 3t minus 4y. Minus 4 into y. What is your y? 14 minus 4t upon 3 is equal to 20. Are you following that? In equation 4, I'm replacing y by 14 minus 40. Then this implies we have 3t. First multiplication, 14 4 times is 56. Minus into minus plus. Or what I can do is, what we can simply do is, you can just leave this negative as it is, and then you simply multiply by 4. No problem. Alright? We have so many choices to work out. So 14 4 times is 56, right? Minus 4 4 times is 16t upon 3. I'm just leaving out this minus as it is at its own position, and with this 4 I'm multiplying both of the terms. Okay? Is equal to 23. Now let's take LCM. What is the LCM here? 3. Here the denominator is 1. So 3 times 3t will be 90. Here 3 cancels out. So we have 56 minus 16. Okay? Is equal to 23. Now let's remove this bracket. In order to remove this bracket, I have to multiply both of the terms by this negative sign. So 90 minus 56 minus minus plus 16t upon is equal to 23. 90 plus 16t, 25t minus 56 upon 3 is equal to 23. Cross multiply. 25t minus 56 is equal to 3 times is 9, 2 times is 6. So your 25t will be 69 plus 56. So your 25t would be equal to 9 plus 6, 15. 6 plus 5, 11 plus 1, 12. So your t will be 125 upon 25. 25, 5 times is 1. Now this value of t, I'm going to substitute here, and we get y. Now, so from equation 5, your equation 5 is y is equal to 14 minus 4 times t, 4 times 5 upon 3. So this implies y equals to 14 minus 20 upon 3. So y equals to minus 6 upon 3. So your y will be equal to minus 2. So we have obtained y, we have obtained t, but that's not it. What do we need? X. No, we have t already. We need x. T means 1 by x. We consider that, right? But 1 by x has been taken to be t. So 1 by x equals to, what is your t? 5. So 5. So if we cross multiply, 5x would be 1. So x will be equal to 1 by. So x is equal to 1 by 5. Y is equal to minus 2 is your solution for a given equations. Alright. So we now work out with the fourth one, question number 1, Roman 4. These are your given equations, okay? We have to reduce them to linear, let's see. So given pair of equations are 5 upon x minus 1 plus 1 upon y minus 2 is equal to. Here your variable is x minus 1. You cannot separate x and minus 1, okay? So 5 upon x minus 1. 5 upon x minus 1. What you can do is, you can simply separate the coefficient from its variable, okay? Now, তুমি কি কৰিব পাৰিব খালি কোএফিচিয়েন্ট আৰু তাই লাগা না ভেৰিয়েবল আৰু তাই লাগা কোএফিচিয়েন্ট দি আলাগ কৰিব পাৰিব here you cannot separate x and minus 1 here you cannot separate y and minus 2 over here you can only separate variable and its coefficient okay to কেনেকা কৰিব this one can be rewritten as 5 times 1 upon x minus 1. Or here coefficient is only 1, so I can simply write 1 times 1 upon y minus 2. Or see, this one though, it's nothing to do here. The coefficient is already 1, no? So there is nothing for you to separate. Is it alright? Is equal to 2. So numerator, if the numerator is 1, you have no problem. If the coefficient is 1, you have no problem. Okay? Here we have separated the coefficient from its variable. And here the coefficient is 1, so there is nothing to rearrange it. Okay? So this is your first equation. And then what do we have? 6 upon x minus 1 minus 3 upon y minus 2 is equal to 1. You separate the coefficient from its variable. 6 times 1 upon x minus 1 minus 3 times 1 upon y minus 2 is equal to 1. Right? So that is your second equation. So see, here we have 1 upon x minus 1. Here also we have 1 upon x minus 1. So you can replace 1 upon x minus 1 by b. Okay? Here we have 1 upon y minus 2. Here also we have 1 upon y minus 2. So 1 upon y minus 2 can be replaced by b. So put 1 by x minus 1 as u. 1 upon y minus 2 by b. Then what will your equation 1 become? Equation 1 becomes what? Yeah. 5, this 1 by x minus 1 is, and then plus, what do we have? Is equal to, that is your equation number 3, right? And what will your equation 2 become? Equation 2 becomes 6u minus 3v is equal to, alright, this time let's go for elimination, because I can multiply equation 3 by 3, and we will add or subtract, opposite sign, yeah, we will add the equations, okay? So first of all, let me multiply equation 3 by 3 so that the coefficient of v will be equal, and then since they have opposite signs, so we can add the equations. So multiplying equation 3 by 3. So if you multiply equation 3 by 3, then 3 5 times is 15u plus 3v is equal to 6. Equation number 5. Now I'm going to add equation 4 and 5. So adding equation 4 and 5. Equation 4, 6u minus 3v is 1. Equation 5, 15u plus 3v is equal to 6. Adding plus minus 3v plus 3v cancels out. 6u plus 15u, 21u is equal to 7. So u will be equal to 7 upon 21. 7 1 times, 7 3 times. So u is 1 by 3. So this value of u can be substituted in any of the equation that you prefer. Suppose equation 4 or maybe 3. I choose 4, suppose. From 4, from equation 4, your equation 4 is 6u minus 3v is 1. 6u, so 6 into u, 1 by 3. And then minus 3v is 1. 3 2 times is 6, right? 2 1 times is 2, minus 3v is 1. Minus 3v is equal to 1 minus 2. Minus 3v is equal to minus 1. So v is 1 by. So we have obtained u, you have obtained v, but that's not it. I went x and y. Okay. Now you have assumed that 1 by x minus 1 to be equal to u. So 1 upon x minus 1 equal to u. You have obtained as 1 by 3. So we can cross multiply. X minus 1 will be equal to 3. So x will be equal to 3 plus 1. So x will be equal to 4. Okay. And then 1 by y minus 2 you have considered to be v. 1 by y minus 2, and then your v is also 1 by 3. Cross multiply, then y minus 2 will be equal to 3. Then y equals to 3 plus 2. Therefore y equals to, so x equal to 4, y equal to 5 is the solution for your given equation. Okay. So we look into Roman 5. Roman 5, let me write down the questions. 7x minus 2y upon xy. 7x minus 2y upon xy is equal to gimana sih? 7x minus 2y upon xy equal to? Huh? Right, as ni no? Sabi ni. And then the other one? 8x plus 7y upon xy is equal to 15. You're sure? Both are correct? No. So we shall start with question number 115. These are your given equations. Looks really simpler now. So your given pair of equations are 7x minus 2y upon xy is equal to 5. See, there is nothing to be done. You need not cross multiply. The only thing that you do is, why don't you separate the terms on the numerator? On the numerator, we separate the terms. Let's separate the terms then. 7x upon xy minus 2y upon xy. See, this is how we separate. No. If we separate the numerator, then if we separate the terms on the numerator terms, okay, then we have to write denominator in each of the terms of the numerator, okay? Now, if we separate the terms of the numerator, then we need to write the denominator for both the terms of the numerator. Here x gets cancelled, here y gets cancelled. So 7 upon y. This is not linear, so we will rearrange it and write 7 times 1 upon y. So that 1 by y can be replaced by some variable which will be linear. 2 upon x can be rewritten as 2 times 1 upon x. So that 1 by x can be replaced by any other variable which is linear. Okay. And your second equation, 8x plus 7y upon xy is equal to 15. The same thing, I can do it here. Separate the terms of the numerator. Okay. Numerator the terms separate korile. Denominator do ito duida terms to kabili kiwale lagi. Okay. Only if you separate the terms on the numerator. Is equal to 15. X cancel, y cancel. So 8 by y, this is not linear because when I bring y to the numerator, it will be written as y to the power minus 1, right? So we can rearrange this. 8 into 1 upon y. 7 into 1 upon x is equal to 15. Did you do this way? Okay. So this is 1 by y, this is also 1 upon y, so 1 upon y can be replaced by u, linear. This is 1 by x, this is also 1 upon x, so 1 by x can be replaced by another variable, say v. So put 1 by x as u, 1 by y as v, then your equation number 1 becomes, 7u. No, what I'm doing. We are putting 1 by y to be v. And 1 by x as u. Okay, do not get confused over there. So I'm putting, 7 times 1 upon y. 1 upon y, we are taking it as v. So, or if you are having confusion over here, then 1 by y can be replaced by u, no problem. And 1 by x can be replaced by v. Right? Then your equation 1 becomes 7 times 1 by y. 1 by y, I'm replacing it by u. So 7u. 7u minus 2 times 1 by x, 2 times v, right, is equal to 5. You have a new equation 3. And then your equation 2 becomes 8u plus 7v, right, is equal to 50. Question 5. Which method would you like to prefer? You can do it by substitution, by elimination, by cross multiplication. I want to try it by substitution. Okay? Let's do it by substitution. Then from equation 3, your equation 3 is 7u minus 2v is 5, right? Then 7u would be equal to 5 minus 2v gets transposed as plus 2v. Minus 2v gets transposed as plus 2v. Then you have u to be 5 plus 2v upon 7. That's a new equation. So substitution means from the first equation I have found u in terms of v. Okay, I found u. That value of u has to be substituted in the next equation 4. So substitute u as 5 plus 2v upon 7 in equation 4. That's equation 4. 8u. So 8 into u, your u is 5 plus 2v upon 7, right? And then we have plus 7v is equal to 15. 8u. 8u. So 8 times your u, right? Correct? Let's multiply by 8. 8 5 times is 40. 8 2 times is 16, and v upon 7 plus 7v is equal to 15. We have to take LCM. If we take LCM, then 7 cancels out. 40 plus 16v. 7 times is 49v, right? You got that way? 40 plus 16 plus 9, 49. 9 plus 6, 5, 4, 5, 65v, yes, correct. Upon 7 equals to 15, right? Now we can cross multiply. If you cross multiply, then 40 plus 65v. 40 plus 65v will be equal to 17, or 7 15 times is 105, right? So 65v is equal to 105 minus 40. So 65v is equal to 65. So your v is equal to 1. Very simple. V is 1. Then let me find u by substituting v over here, equation 5. So from equation 5, your equation 5, u equals to 5 plus 2 times v. V is 1 upon 7, right? U equals to 5 plus 2 upon 7. So u is equal to 7 upon 7. So u is also 1. But that's not it. It's not our conclusion. We want the solution. Okay? We can obtain the solution only after finding x and y. Okay, see? 1 by y, you have considered it to be u. Now, 1 by y, you considered it to be u. So 1 by y is equal to u is 1. So if you cross multiply, y will be simply 1. You have considered 1 by x to be v. So 1 by x equal to v is 1. If you cross multiply, you get x is equal to 1. So x equals to 1, y equal to 1 is the solution for the given equations. Alright? Now we go for question number 1, Roman 7. Roman 5 and 6 are exactly the same. Okay, so we have worked out with Roman 5. Similarly, you can try out 6. Now we go for 7. So your given pair of equations, are 10 upon x plus y plus 2 upon x minus y is equal to 4. Let me close the door. So this is your first equation. Let me separate the variable and its coefficient. Here see, x and y are given in sum, are expressed as the sum, no? Here x and y, there is x plus y, this is x plus y, you cannot separate x and y, okay, over there, yeah, on the denominator. The only thing that we can do is, we can separate the variable and its coefficient. So 10 upon x plus y can be rewritten as 10 times 1 upon x plus y. 2 upon x minus y can be rewritten as 2 times 1 upon x minus y. You multiply back, you get the same thing, right? Is equal to 4. This is your first equation. And your next equation, 15 upon x plus y minus 5 upon x minus y is equal to minus 2. Separate the variable and its coefficient. But if something is added or subtracted to the variable in the denominator, then they are inseparable, okay? So what I'm going to do is here, 15 times 1 upon x plus y minus 5 times 1 upon x minus y is equal to minus 2. That's how we do, right? Now see, we have 1 upon x plus y. We have 1 upon x plus y in the other equation also. So 1 upon x plus y can be replaced by another variable which is linear, say u. 1 upon x minus y over here, 1 by x minus y over here again. So 1 upon x minus y can be replaced by any other variable which will be linear. So put 1 by x plus y to be equal to u and 1 upon x minus y to be equal to v. Then your equation 1 becomes, what will your equation 1 become? 10u plus 2v is equal to 4. This is your equation. And what will your equation 2 become? 15u minus 5v is equal to minus 2. See, we could have reduced this equation. I could have make it more simpler. We can divide both sides of this equation by 2. Then this would have become 5u. This would have become v. This would have become 2. Then elimination method would have been much easier over there. But that's no problem. We can always do it by any other method again. So let's try by substitution. Okay. So in order to solve equation 3 and 4 by substitution, I'm going to take equation 3 and I'm going to find u. That u can be substituted in the other equation 4. Now, from equation 3, your equation 3, 10u plus 2v is equal to 4. So 10u equals to 4 minus 2v plus 2v transposed as minus 2v. So your u would be equal to 4 minus 2v upon 10. I want to make it more simpler. So what you can do is take command from the numerator. What is command from the numerator? 2 is command from the numerator. Then we have 2 times is 4 minus 2 times v is 2v upon 10. 2 5 times is 10. Then we have u is equal to twice minus v upon 5. This is your equation. So we have found out u, even though it is in terms of v. So this u can be substituted in the next equation 4, right? So substitute u equals to 2 minus v upon 5 in equation 4. Equation 4, wherever there is u, you just replace it by this quantity. Equation 4 starts with 15u. So 15 times u, your u is twice minus v upon 5, right? 15. So 15 times your u. Minus 5v is equal to minus 2. 5 3 times is 15. 3 times 2 is 6. Minus 3 times v is 3v. Minus 5v is equal to minus 2. 6 minus 8v is equal to minus 2. Minus 8v equals to minus 2 minus 6. Minus 8v is equal to minus 8. 8v is 8 means v is 1. So v is 1. Substitute v as 1 over here, then you get u. So from equation 5, your equation 5 is u equals to 2 minus v. Your v is 1 upon 5. So this implies u as 1 by, I think it's correct. So v is 1, if v is 1 by 5, we have no problem. Now we need x and y. We need x and y. See, you have replaced 1 upon x plus y as u. You have replaced 1 upon x plus y by u. Now, 1 upon x plus y is equal to u is 1 upon 5. If you cross multiply, x plus y will be equal to 5. X is unknown, y is unknown. This is a new equation. Equation number A. Let it be A. Okay? Because we have up to 5 equations. No, let me not write 6, 7, 8. No. And we have replaced 1 by x minus y by v. So 1 by x minus y is equal to v is 1. So if you cross multiply, x minus y will be equal to 1. Equation number B. We need to solve A and B now. This is plus y, this is minus y. We can add equation A and B. So adding equations A and B. Your equation A is x plus y equal to 5. Your equation B is x minus y equal to 1. Plus y minus y can be eliminated. Twice x is equal to 6. So x is equal to 3 because 5 plus 1 is 6. So x will be 6 upon 2. That is 3. So we have obtained x. So this x you substitute in equation A, you get y. So at last, from equation A, from equation number A, x plus y is 5. X plus y is 5, but your x is 3. So 3 plus y is 5. So this implies y equals to 5 plus 3, transpose it as minus 3, then y is equal to 2. So x equals to 3 over here, y equals to 2 over here is the solution for the given equations. So we come to the last question of question number 1, Roman 8, solution. So a given pair of equations are 1 upon 3x plus y plus 1 upon 3x minus y is 3 by 4. See, denominator has been expressed as the sum of two variables. Here denominator has been expressed as the difference of two variables. If the denominator has been expressed as the sum of two terms, sum of two variables or difference of two variables, we cannot separate them. The only thing that we can separate here is separate the variable and its coefficient. That's all. Okay? So here the coefficient is only 1, so there is nothing to separate, and we cannot. The denominator has been expressed as the sum of two variables. Here is the difference of two variables that we cannot separate. And the coefficient is only 1, so no arrangement is required, so you just make it as equation 1. Alright? Now the second equation, 1 upon 2 times of 3x plus y minus 1 upon 2 times of 3x minus y is equal to minus 1 by 8. Now, what is your coefficient here? Your coefficient is not 1 now. What is your coefficient? 1 by 2 is your coefficient. Now see, in both the terms, we have 1 by 2 as the coefficient. So can I take 1 by 2 as a common? Right? 1 by 2 is common in both the terms, right? Here also, here also. So if I take 1 by 2 common, then we have 1 upon 3x plus y as its first term, minus 1 upon 3x minus y as its second term is equal to minus 1 by 8. Can I cancel like 2 4 times is 8? So 1 upon 3x plus y minus 1 upon 3x minus y is equal to minus 1 upon 4. Equation 2. Now see, this is 1 upon 3x plus y, this is also 1 upon 3x plus y, same. So I can replace this by another variable u, which will be linear. We have 1 upon 3x minus y, we have 1 upon 3x minus y. So we can replace 1 upon 3x minus y by another variable v. So put 1 upon 3x plus y as u, and 1 upon 3x minus y as v. So your equation 1 will become, yeah, this whole thing is u only, right? U plus, this whole thing is v. So the 3 by 4, that is equation 3. And your equation 2 will become, this whole thing is u only, minus this whole thing is v is equal to minus 1 by 4. We can do by elimination.